So now we move on to arteriosclerosis. This is super high yield. Pay attention with everything you have because the board examiners absolutely love this. Now the arterio indicates we're talking about arteries, and sclerosis indicates that there is some sort of hardening going on of the vessels that we are interested in, which are our arteries. So what about arteriolosclerosis? We added some letters in here. So by adding this L and O, it means that we're now talking about the smaller arterioles. There are two types of arteriolosclerosis that we need to know about. Number one, it's hyaline arteriolosclerosis, and this can occur in hypertension or also in diabetes mellitus. So here's the first image that we're looking at. Do you see the pink material that is thickening the vessel and narrowing the lumen? Here's the very tiny lumen. These blue arrows are pointing to this pink material. The term hyalinosis comes from the glassy and pink staining material here in the vessel lumen. When we stain it with hematoxylin and eosin, it appears very pink. In hypertension, the high pressures will literally pound proteins into the basement membrane. So the basement membrane that the endothelial cells sit on is being damaged from these chronically high levels of pressure pushing plasma proteins into the basement membrane. This basement membrane disruption leads to a response from the endothelial cells. What do the endothelial cells do? Well, to reinforce the basement membrane because of this chronically high pressure they're subjected to, there's going to be an increase in collagen deposition. And then guess what stains pink on H&E? Hematoxylin and eosin staining. This collagen that's been depositing in response to the high levels of pressure and the proteins that are being pushed into the basement membrane. So what about the hyaline arteriolosclerosis that you see in diabetes mellitus? The same result happens, but instead of the shear forces driving proteins into the basement membrane and damaging that way, the high levels of glucose will lead to non-enzymatic glycation of proteins. What proteins are we talking about? The proteins that sit on the endothelial cells. This leads to formation of reactive oxygen species. Guess what reactive oxygen species do? They damage the endothelial cells. And when endothelial cells are damaged, they dysfunction. So these dysfunctional endothelial cells can actually start to release a lot of cytokines in response to the damage they're undergoing. So they tell fibroblasts to make more collagen. And guess where the collagen is going to be seen on your H&E stain? It's the pink glassy hyaline material in the middle. This is a different pathologic process, but we still get our pink staining collagen narrowing the vessel's lumen. Now the other type that we need to discuss is hyperplastic arteriolosclerosis. This is seen in settings of severe hypertension. People that are hanging around 180 systolic and 120 in diastolic pressures is what we're talking about when we say severe hypertension. Now why does this happen? Why does it look like this? So the endothelial cells and the basement membrane are severely damaged in the setting of very elevated blood pressures. The damage leads to a compensatory process in which multiple layers of basement membrane and smooth muscle cells add concentrically. Concentrically meaning towards the middle of the vessel lumen. Note here how there's one basement membrane with endothelial cells on it. There's another basement membrane with endothelial cells on it. There's another basement membrane, and so on and so forth until you can severely decrease the diameter of the vessel lumen, leading to decreased blood flow. Now the layer of this cross-section on biopsy looks just like the layers of an onion. This is where the term onion skinning comes from. So this fibrinoid necrosis is also the result of this process. So fibrinoid necrosis refers to the fact that damage to the vessel wall will allow fibrin to sneak in to these onion skin layers. The fibrin can deposit around these layers and you get the fibrinous necrosis that's associated with onion skinning from very, very elevated blood pressures. Alright, now we advance to arteriosclerosis, specifically Monckeberg. So Monckeberg's arteriosclerosis will hopefully soon only be referred to as medial calcific sclerosis. The name tells us that there is hardening or sclerosis of the tunica media, secondary to something to do with calcium. So for some reason, calcium is thickening the tunica media and making it hard. Here's an image of what's going on in this disease. These are classically referred to as pipe stem arteries because they look like the shape of the stem on a smoking pipe. So the femoral and the popliteal arteries show significant calcification. That's why they're showing up on the x-ray. It's rather obvious from this radiograph that there is something showing up when these x-rays are hitting the calcium in these arteries. There is no obstruction of blood flow because the media is calcified. It's not hypertrophic and it does not decrease the size of the lumen. A 65-year-old man has diabetes and hypertension. What disease process do you suspect in his small arteries? So hypertension uses brute force to slam plasma proteins into the basement membrane and cause damage that way. Diabetes mellitus, on the other hand, uses non-enzymatic glycation of endothelial and vascular smooth muscle cell proteins to cause the creation of reactive oxygen species that leads to basement membrane damage and endothelial cell dysfunction in that way. The end result, though, is arteriosclerosis, which is hyaline thickening of small arteries that occurs in hypertension or diabetes mellitus. So this gentleman is rather unfortunate in that he's suffering from both disease mechanisms, contributing to small vessel disease.